Our first example here is just any old machine. It's non-specific because any machine is governed by, and when we say a machine, we know that it's not specifically a lever or wheel and axle or anything like that. So we are limited to just our normal run-of-the-mill mechanical advantage equation that uses force. All right. There we are. Now I got to write it correctly. Mechanical advantage is equal to the load force, what you get out of the machine, divided by the input force, what you put into the machine. Okay, so this says what is the machine's mechanical advantage? Which one of these is F load and which one is F input? Yeah. 100 newtons is which one?
The load.
Okay. How did you know 100 newtons is the load?
Because it says weight behind and the 25 newtons is force. So I know it's input.
What if I hung a weight from something as the input? Okay.
It says the machine can lift it. Can lift 100.
That's what the machine is doing. Yep. Your reasoning worked this time. It might not work every time, since you could have a machine that sort of works without your direct input. So you have to identify. You're right. That is the load. But we know that because that's what the machine is doing. And then that means the input, what you do. So that's the person pulling the 25 newtons.
So is what the person does, is that always the force?
That's the way I'll be wording them. If a person's doing that, will always be the input. It is possible to have an input force done by something else. We see that with our mousetrap car. An input would be the spring pulling on our lever. So that would be an input. The load would be however much force is applied to the end of the string, and then onto the axle. Okay, so we just have to divide these. Load force, 100 newtons. Input force, 25 newtons. We could probably do that one in our heads. What about units? No units. The newtons and newtons cancel each other. So no units on this. It's just a ratio comparing one to the other.
If I can run the mile, 7 minutes.
But make sure your tires aren't flat.
Doesn't. First thing to think about with this, so we're trying to lift a 150 Newton weight. So is that 150 newtons a load or an input? How did? Say that again. Why is that a load? Again, we can't just go by weight. You're right that it's a load. That's what's coming out of this machine, right? We're getting the machine to lift it. So that would be our load. And we're given the mechanical advantage. So one thing to consider with this, to make it quite a bit easier, I think, is if we've got a mechanical advantage of 3.5, does that mean the machine is making it easier for us to lift it or more difficult?
More difficult.
Check your notes from yesterday.
Easier.
MA less, yeah, greater than 1.
So it's
Making it hard to make.
Are you sure you wrote that down right? Or are you sure that's so
less than 1?
machine is greater than 1?
Greater than 1.
MA is greater than 1.
Less force is needed.
Less force is needed. So if this is what we're getting out of the machine, we need to apply less force.
So did I write that wrong?
So how do you know what to
The one that I have less force in is MA is greater than 1.
Yeah, so less force is needed. So what that means is you would have to apply less
Oh,
force
so
than normal to the
MA
machine.
That is greater than 1.
Right. This is
Okay.
greater than 1, so
I got it.
you will have to apply less force.
Okay.
That can help you once we get the understanding there.
Is that the answer?
That'll help. No, we're not there yet. That'll help you by figuring out that, okay, my force is going to be less than that 150 newtons. This is what the machine has to apply to lift it. It's the weight of the object. So my force is going to be less. How do I solve this? I'm going to move this down just to make it easier. How do I rearrange this? I want to find how much force do I need to apply. That's the input. How do I solve that for input force? Casey?
Times the force, times the load, like,
Multiply by load force?
no.
Is that what you're saying?
I don't know how to explain it. You have to get to F to where the MA is.
Okay, we need to get this F input up here.
Yeah.
Give me, yeah. I saw hands over here too.
I was gonna say, times the input,
Multiply both sides by input.
get over there.
Okay, let's give that a try. I'm just going to abbreviate that as F in. So if I multiply both sides by that, what happens on the right?
That cancels out.
Cancels out.
Okay, and I'd be left on the left with F input times MA
Then
is equal to F load.
to divide the MA.
Right. Somebody's been paying attention in algebra. Very good. Okay, so those two MAs cancel. That gives us F input here is equal to the F load over MA. Essentially, they traded places, but now we can.
We did the same thing for like the acceleration.
We did the same. Yeah, the algebra doesn't have that many rules. One.
So all we needed to do was divide 150 by 4.5.
Right, but how are you going to remember that that's what you need to do?
Okay.
Right, that's the trick.
So if you're looking for the F input, like,
Well, so one thing you can do to help you with this is with the reasoning that a mechanical advantage of 3.5 is going to make it easier. Okay, well, if I'm going to make it easier, I'm either going to multiply or divide with this. I'm not going to add or subtract in this, in that formula. So if I'm making that smaller, I must divide. Yes, Sean.
So if you're trying to find the F load, would you do the same thing but with the F load? But
You would stop before you divide by MA
So
because
you
we'd
would
have
do
F load is equal to MA times input.
so
Yep.
would the F load times MA equals
F input times MA equals F load. Right? If we just stopped up here, we crossed out the F input, we're done. F load is equal to F input times MA.
Okay.
Okay, but what do we have here? Yes.
I just have a question.
Okay, hold on to it 1 second. I want to solve this. And then we'll get to your question.
42.8.
Said 42.85, so about 43. Any units on it?
no, because of no.
Oh,
Yes,
wait,
you
yeah.
do
Put a unit.
Oh,
It
Nope.
is newtons.
Newtons, that's not
Yeah.
canceled anymore. 43 newtons. What was your question?
Okay, so like, say we have a question, like another question exactly like this, and it's like, it gives us that load and it gives us the mechanical advantage, so all we have to do is divide the load by mechanical advantage.
Right, but bear in mind that we've got 4 equations here that we're going to be manipulating. It's pretty hard to remember. I'll give you what each of them looks like. But it's pretty hard to remember, well, if I have to do this, then this is what it looks like. Now you're adding, 3 or 4 more equations per.
Well, don't you think it's harder to like remember all like 5 steps?
No, I think it's much easier because you do this all the time in algebra. Yes, sir.
So to find F load and F input, are you still doing timesing F input?
Multiply by F input because you've got to get F input. If you're solving for F input like we did, you have to get it on the top of the fraction. It starts out on the bottom. The easiest way to do that is to multiply. If you want to solve for F load, you have to get F input out of the bottom. So you're going to multiply. So whenever you've got a fraction like that in this or other things, first step's going to be to multiply. When we saw velocity is equal to distance over time, If we wanted to solve for distance or time, our first step was to multiply by the time and get it out of there. Same thing with this.
So then would load be F input times NA?
Yep. Okay, so this, now we've got a lever, once we've got a specific, recording. Probably get closer to the camera.
Thought you stopped.
I stopped in between, but now I started again. Now we've got a specific machine. That means we've got, not only can we look at the forces to say what the mechanical advantage is, like we did on the last two problems, we can also apply a specific calculation based on the geometry of this. And for a lever, remember, its mechanical advantage is also equal to the distance away from the fulcrum that the input is placed divided by the distance away from the fulcrum that the load is placed. And it asks, what is the mechanical advantage? So we have to define the other two. So Isaac, how did you know that the 1.5 was your input, 1.5 meters? Because that's the force you are applying, which makes it the input. What's that? D stands for distance. Yep, and it'll be in meters. So that's 1.5 meters. The load is, where is the weight that we're trying to lift on there? So that's 0.15 meters. Now we have enough to divide. We can, and this again is one that we can probably do in our head. So input distance, 1.5 meters. Load distance, 0.15 meters. So what's our mechanical advantage? 10. What units are on that? No units. Meters. Meters cancel with meters. Okay, this one is more challenging because we have to consider both ways that mechanical advantage can be calculated. There are a couple different ways to solve this. They're both essentially the same. I'm going to actually show you the little bit shorter way to solve this. And the first thing we're going to do is combine the two different ways that we can calculate mechanical advantage. Now we just talked about for a lever, we can always say D input over D load. That works for levers. But then another thing that's equal to that every time is just the general formula for mechanical advantage, which is F load over F input. Now what should we call input and what should we call load? We don't really have an obvious one here. Good. What are your thoughts, Caleb?
The skinny kid is the F load.
Okay, you want the skinny kid to be the load. That's fine. Essentially all we have to do is say one of these kids is going to be the load, the other kid is going to be the input. Yeah.
Wouldn't the input be 2.5 meters for both?
Well,
That's what I was thinking.
there's really not one that's the input and one that's the load since two people are involved. They're both sort of putting in some. So instead as Caleb suggested, we're just going to say one of these is the skinny kid, one of these is a big kid. So and what he had picked was that the load would be skinny. So we're just going to replace the word load with skinny for this. And input will be our big kid. Now, we don't need to solve for mechanical advantage in this, right? It doesn't ask us to. So we could use just maybe this part of it, solve for mechanical advantage, and then go back and solve for this, but we can actually shorten this up by just using this portion because we can say what most of these are. So let's put them down. Big, skinny, F big, F skinny. Okay, and what do we know from the problem? Okay, give it, which one's which?
The newtons would be the F.
Okay, those are the forces, right. So skinny kid is 150 newtons in weight. Big kid is 250 newtons in weight. Which one are we trying to find?
The D big.
D big, the distance the big kid would be there. Okay, and so D skinny, that's how far is the skinny kid sitting, and that is 2.5 meters. Now I'm going to keep this in formula, and I'll rewrite it here just to make it shorter, a little shorter. So this would be D sub B for a big kid over DS, and that's equal to FS over FB. I want to solve for this dB. What do I do? That's my X. Yes, Meg. Times, multiply both sides by ds, because I have to get it off of the bottom here, right? So if I multiply both sides by ds, it does. It cancels those two. And what's left is that the distance for the big kid, these two are on the top, so the force of the skinny kid times the distance of the skinny kid over the force of the big kid, and now I can put in my numbers. 150 newtons times 2.5 meters over 250 newtons. Now before we evaluate this, I should ask this before, is the big kid going to have to be closer or farther away than that 2.5 meters? Closer. So keep that in mind. This will produce a shorter distance. It'll be more than half.
It'd be 1.
What else somebody do it for? 1.5 meters.
I had that from the start.
As a guess?
No.
Oh, well then you did it right. That's good. Oh yeah, of course. I picked the numbers again so that they're multiples of each other. Good.
I can live for it.
Pulleys can be very easy, but you've got to kind of grasp the rule. As several people have said, the rule for pulley systems is the mechanical advantage is equal to the number of support ropes, or the number of ropes actually pulling up on the weight or the load. So if we've got our load down here, we want to look above. Anything pulling up directly on it or on its pulley is a support rope.
Are those hooks at the bottom of those?
Yeah, so it's just a hook that's hooking together.
Oh.
So here we've got 1, 2, 3 segments of rope all pulling up on that mass. So that means the mechanical advantage is 3. And that's all you have to do.
I thought you were going to have to divide it by the mass.
Nope. This one doesn't count because it's pulling down. This is where you'd apply your force. What this means is that, so it's greater than 1. It's easier to lift this than normal.
It's 3 times less.
It's 3 times less, 1/3 of what you'd normally say. So if this were 3 pounds, you'd only have to apply 1 pound of force to the rope.
That's all we have to do.
Wouldn't the one on the right be going down though? Because if you're pointing it down, how it seems like the
This
on
one?
the far
All of
left
these
is
are going to
going
be shortening as the weight goes up. That's another way to look at this. So, and they will all apply attention. So the rope goes up here, goes around like this. This rope can't push. Ropes are really terrible at pushing. So the tension is still pulling up on this mass.
I'm gonna see how that works. Like, see someone actually pull it.
Maybe. Okay, here is our pulley system. Pulley systems are nice. We can just inspect them to find the mechanical advantage. What is the mechanical advantage? Casey?
Oh my god! What was that? Look,
Yes, Casey.
1.
How do you know?
Because there's only one thing. So it'll be the same.
There's only one string pulling up?
Yeah.
Actually, no.
There's 2, but the other one's pulling out.
Oh, but there are 2. How many strings are pulling up on the pulley or the mass itself? 2.
Oh, so then it'd be 5 kilograms.
Okay, mechanical advantage is 2.
Dang.
What do we want to find from this?
The force needed to lift.
Force needed to lift, which we usually abbreviate how?
F
Input. So this tension is actually our F input. And that's what we want to find. So that means we should know the F load. Okay,
Oh,
it is not 5 kilograms. There are 2 things wrong with that. 1, it's an incorrect number. 2, it's an incorrect unit.
I just don't know like.
How much force are we getting out? How much force is being applied to this in order to lift it?
Is there 2 newtons?
Not 2 newtons. How'd you get 2 newtons? No?
it's crank.
20. How did you get 20?
Because the mechanical advantage is 2 and you need to pull it twice as much string.
Okay, I get where you're coming from there. Also incorrect. Okay, think about this. We've done this a bunch of times. How much force do I have to apply to this to lift it?
How much is that?
1 kilogram.
However much
I
it
know,
weighs.
1 gram.
However much it weighs. Which in this case, it's 1 kilogram.
So you need 1
Yeah,
kilogram.
Justin.
5 kilograms?
No.
Would it be 10 newtons because the next one is 10?
No, let's look at this. So
10
this was 1
kilograms.
kilogram.
10 kilograms.
Louder doesn't mean correct. This is 1 kilogram. I have to multiply that. This is a force, right? To find force, you have to multiply mass times the acceleration. So the force of gravity here is this mass times g, 9.8 meters per second squared. So in our case here, it's 10 kilograms times 9.8 meters per second squared.
That is confusing.
This is exactly what we've been practicing many, many times.
How though? How is that?
98.
Oh, so because you're pulling against gravity?
Well, if you're lifting something, you have to consider its weight, not just its mass, its weight.
Yeah, but wouldn't it be the same way if you were doing the other way?
Yeah.
It sure would,
How come we didn't do it that way?
because I didn't give you a mass in the rest of them. I gave you a weight. I gave you a value in newtons rather than in kilograms.
Adapt to the scenario.
Oh, so you're trying to find the newtons.
We're trying to find the other force that we'd have to apply here in order to lift this weight. But I only gave it to you in mass here because I wanted to practice this. So now we've got a mechanical advantage. We want to find an input. We have the load. Remember, mechanical advantage is equal to F load over F input.
And you find the F inputs like times
Multiply both sides by F input, right?
and then you divide by the mechanical advantage.
Those two cancel, right? And then we divide by, you're walking me through it. So F input will be F load over mechanical advantage. Think about this again. Do we, with this pulley, do we expect it to be easier or more difficult to lift it?
Easier.
Easier. So we should apply less than 98 newtons. And we can think about that. Well, I'm only going to multiply or divide. If I want less than 98 newtons, I have to divide by that, which is exactly what we've got.
49.
49.
What? I thought it was
40, 98 newtons divided by 2,
Oh,
49.
The tension is 49 newtons.
Right.
there's something on my calculator.
So yeah, that's literally